Cool. Chapter 3 is similar to let me start that over again, shall we? Need to figure out why my pen keeps resetting. All right. So chapter 3. A lot of chapter 3 is going to be similar to what we were doing in chapter 2. Just instead of having equations all the time and solving factors with equations, we're going to have inequalities. We're going to replace the equal sign with a greater than, or a less than, or a less than or equal to, something like that. But there's definitely additional stuff in there. It's not just a total repeat, change one sign. We're going to start out section 1 is 3.1, graphing and writing inequalities. So graphing and writing inequalities. And first I'm just going to kind of do like my Roman numeral 1 and say some terms. Kind of we need to get some terms out of the way before we can really go through and do much with this. And there's not a ton of new stuff in today's notes, so I think it'll go pretty fast. So first thing, an inequality. Kind of the short version is an inequality doesn't have an equals. It uses one of those, less than, greater than, something like that. So uses one of these. So it'll either be like the less than, or maybe a greater than, or a less than or equal to, or a greater than or equal to. But you need to have one of those four signs in order for something to officially be an inequality. So for example, you could say if you wanted to, x is less than or equal to 5. So that would be an example of an inequality. When we're looking at those, then the solution...
The solution is the next term.
Yeah. The solution to an inequality isn't going to be just a single number like before you get like a x equals 7 or something like that. Now it's going to be any value that for the variable that makes the inequality true. So any value for the variable that makes the inequality true. So when we had that x is less than or equal to 5, 4 would be part of the solution. 4.99999 would be part of the solution. Negative 17 would be part of the solution. So then Roman numeral 2 is identifying solutions. Bless you. So if you want to identify a solution, basically you put a number in for the variable and see if it works. We're going to solve for solutions soon, and it's a whole lot better. But if you want to just identify a solution, put a number in for the variable. And see if it works. And this is going to kind of lead us into our Roman numeral 3, where we end up like graphing the thing. So for example, if we had x is less than 5, you could take and say, all right, would 3 be a solution to this? Yes, because 3 is less than 5. You know that that's true. Would 7 be a solution? No, because you couldn't say 7 is less than 5. That wouldn't work. It's not less than 5. Work for you? If this had been x is less than or equal to 5, would it be fair to say 5 is less than or equal to 5? Yep, because it's the or equal to part and so on. All right, very last section in today's notes. Roman numeral 3, graphing inequalities. So if I were to take and do a x is greater than 7, something like that. When we graphed these, Do we use a coordinate plane like this, or do we use a number line like that? Nope, just the number line. Because it only has an x value, it doesn't have a y value, so there's no reason to have the vertical in there. So if we have a 7, I'm just going to put 7 there in the middle. Unfortunately, I'm still on my eraser, but if I put 7 here in the middle. Do we do an open circle or a closed circle? 'Cause remember that? Is 7 going to be part of my solution? Open circle. Because 7 is not greater than 7, so we do an open circle. Anytime you have less than or greater than, it's going to be the open circle. And we want to say x is going to be all the numbers that are bigger than 7 or smaller than 7. Bigger. So then we take and shade this right-hand side. Make sure you make the arrow bigger as well. Last year I had some people that would just do like kind of a little squiggly shading off to the right, but not have the arrow, and I'd mark them down. It doesn't contribute to goodwill and peace in class. But what this is trying to say is it's saying all the numbers that are bigger than 7 are part of the solution all the way down to 7. So 7.01 is a solution, it's bigger than 7, but 7 itself is not. Yes? We could take and do the same sort of thing. Maybe I'll pick a different one and we'll say x is less than or equal to 10. Actually, let's make it a negative 10 even. Why not? If you get this x is less than or equal to negative 10, then we have our number line. So given this thing here, we could, if we wanted to, and I wouldn't write this if I were you, but what Jake was saying is that you could say negative 10 is less than or equal to negative 10. That's true because of the or equal to part, that the less than is underlined. So you can take and put a mark at negative 10, and now we fill in the circle. So you want to say it's including that point. Now for a x is less than that, do we shade to the left or shade to the right? Yep, less than you always shade to the left. Yep. Yeah, unless you put it in the other order, like negative 10 is greater than or equal to x. So this here, then, you still would shade to the left because x is less than or equal to negative 10 if you read it from right to left. Kind of thing. Questions? This is pretty much review. Is that true for people?
Yes.
Okay. If you got all that, if you get all those right, feel free to skip this, but this is kind of the quick summary. You have an open circle. When you graph the answer, you have an open circle with which two inequalities? Less than or greater than. So open circle is going to be if you have less than or greater than. You have a closed circle. Those are when it could be that endpoint. So less than or equal to or greater than or equal to. And then for that whole like shade direction, if you have the variable on the left, so like what we had over here, when this variable is on the left side, then you could say that it points in the direction of which way you shade, like Aiden was saying. But if you switch the variable around, like this one here, then that doesn't work anymore. So what the book encourages you to do is this. And this is going to come in handy. If you understand this now, it'll come in handy down the road when we start like doing shading inequalities on like a coordinate plane. So when you're starting to get things with an x and a y, and you're trying to shade them on something like this. So what the book encourages you to do is pick a number on one side of the endpoint and see if that works. So I'm going to kind of write it out like this. So pick a different number. And by different, I mean if you had like x is less than or equal to 10 or negative 10 like we had. So pick a different number. So pick a different number than negative 10 in that last example. Put it in the inequality. So put in for the variable. And then if it works, shade that way. And I'll show you what I mean in just a second. If it doesn't work, shade the other way. And this probably feels like a little bit of overkill, for those of you that you're fine doing this, but like I was saying, it's going to come in handy when you start getting like x's and y's in there. Then it's a lot less clear which way you shade. And I'll scroll back down to that in a second. But what I mean is this here. If you take this one that we were doing before, so I need a number that's not negative 10.
-2.
Okay, so I heard a negative 15, so I'll try that one first. If we put a negative 15 in for x, is negative 15 less than or equal to negative 10? Yep. And negative 15 maybe you could say is going to be over here somewhere. Because it works, you'd have to shade the direction that includes negative 15. Somebody else had said negative 2. Well, if we had tried, say, the negative 2 instead, so if I had put a negative 2 in there, so negative 2 is less than or equal to negative 10. Is that true? Yeah, it looks pretty bright in the screen. So, true, not true? Not true. Negative 2 is larger than negative 10. It's not less than or equal to negative 10. So that negative 2 would maybe be over here somewhere. We wouldn't shade the way because this doesn't work. You know you have to shade the other direction. So negative 2 isn't a solution. And if you kind of understand that and can apply it, it's going to be a lot easier later on in this chapter for you. Any questions we should look at all together?